the beam problem. Um, I recorded this whole video helping you get through the beam problems, one of your group assignments coming up. And it was a Zoom video. I never downloaded it and then uploaded it to YouTube. The the general rule here is as long as your video keeps getting views, then Valencia won't delete it from the servers. Well, I didn't teach this class last semester, so evidently it hadn't gotten enough views lately. They deleted my Zoom video. So rather than going through that whole process again of giving a whole bunch of hints to the problem, I'm basically just going to show you the solution. So here's our idea. We've got this DE. It's a fourth order non-homogeneous DE. And the left hand, or let's say the homogeneous version is just going to be u to the fourth equals 0. And then the non-homogeneous part where we get our particular solution is just going to be a constant. I can rewrite my DE that says u to the fourth equals this constant. So a bunch of different ways we could get there, but the easiest way is to say, okay, we've got a non-homogeneous fourth order DE. First, we do our characteristic polynomial. And that's going to be something to the fourth equals 0. That's 4 solutions of 0. So lambda equals 0. So what is u equals e to the 0x? That's just a constant. And then for the other ones, I got to keep adding on powers of x. Or another way to think about it, what function, when you take 4 derivatives, do you get 0, a fourth degree polynomial? So my characteristic solution is a fourth degree polynomial with 5 unknown coefficients. And then the easiest way to solve for these is to use my initial conditions. First, I know the fourth derivative of that must be this constant. So take 4 derivatives of this. First derivative of him is 0. His second derivative is 0. His third derivative is 0. His fourth derivative is 0. His fifth, or maybe I said that wrong. Anyways, when you take a bunch of derivatives, all these go to 0. His fourth derivative would be 4 times 3 times 2 times 1 times C1. So that's 4 factorial. You get C1 equals omega. That's not a W, that's an omega, over 24 EI. So here is my general solution. Now I have to solve algebraically for 2, 3, 4, and 5. And we're going to use our initial conditions. We've got this beam that's hovering over some chasm. The ends are fixed. The middle is going to droop a little bit. So my 4 conditions are u of 0 must be 0. U of L must be 0. That means the ends are level with each other. And then we also impose this boundary condition, u prime of 0 and u prime of L must also be 0, meaning there's no deflection. The curve is nice and smooth at the endpoints. Here's where most of the work has to happen. You're going to use this equation, and you're going to get 4 different equations out of this. U of 0, 0, 0, 0, 0. You get C5 immediately. U prime of 0 equals 0. His derivative is 0. His derivative is C4, and so forth. U prime of 0 equals 0 is going to give you C4, must be 0. These guys are 0. Then I have to use these conditions to solve for 2 and 3. That's where there's a lot of algebra. And I'm just going to show you the answer. Like, I guess you could pause and look through all the algebra there. This is what I want you to do. I want you to figure this out. This is what you're going to get. Now, we've got this function. This function tells me how much my beam is bending at position X. We want to figure out where is it going to bend the most. So again, I've got two ledges L apart, and the beam is resting just on the corners of those edges. You know it's going to bend the most right in the middle. It's going to sag right in the middle. Think about like a power line in between two electric poles. It's going to sag, and right in the middle is going to be where it has the maximum deflection. We got to keep in mind here, U measures the amount of the deflection. So even though the beam is sagging down, U will be positive because it measures that distance that we sagged. The distance is positive. Okay, how do you find the maximum of any function? You guys are calculus students. You know this. Take the derivative and set it equal to 0. You're going to get 3 solutions. We already know these two. We know u of 0 equals 0 and u prime of 0, or of L. We know u prime of 0 equals 0 and u prime of L equals 0. Those are going to be 2 of your solutions here. We're going to get one more. You take the derivative of this, you get a cubic. So you get 3 solutions. The third one's exactly what you would expect it to be. When you solve it, you're going to get L over 2. And then a lot of times, groups miss this direction. Now that you found where the maximum deflection occurs, find how big that deflection is by plugging L over 2 back in here. Not in your derivative. You plug it in your derivative, you get 0. Plug it back in here. Then now we're going to plug in a bunch of ugly numbers. So the first thing we got to do here is find the density so that we can find W, which is the weight per unit length. So density, rho, is mass divided by volume. That means mass is rho times volume. So I'm going to have to find the volume of this cylinder. And we're told the density, that will give me the mass. Then W, or omega, it's really omega, is weight, mg divided by the length. The length here is 2. W, I keep saying W even though I told you it's omega. Omega is weight per unit length. And then we're just plugging in. Like, here's my formula. I'm plugging in for W, I'm plugging in for E, and I'm plugging in for I. E is Young's modulus. It's a measure of how much force you have to apply to deform something. And I is the moment of inertia. And you're told both of those. So that's E, that's I. So we're going to get this. Look, I already kind of told you the answer. And then we have to graph. Remember, you will never in your life draw a graph that's unlabeled. Look, why won't that go away? Hide, go away. So we're graphing X versus U. And we know we're at 0 and 2 at both ends. And we know the maximum is going to occur in the middle, halfway at 1. And if we plug in our W, our E, and our L, and our I, we'll figure out how high that is. This is the number you should get. If you don't get that, you done goofed. Like, I gave away all the answers here. All right, I think that's a good place to stop.